Hello YouTube, welcome to my channel. I'm Sri Tips, and I've been asked several times in the comments section of my YouTube channel about the quantity of hydrochloric acid that I use to dissolve gold. And I've never really kept track of it. I've just used my experience to pour an amount of hydrochloric acid in with the gold and then start adding nitric acid to get it to dissolve. And today what I'd like to do, I've got just a touch over 2 troy ounces here of pure gold that I just got done refining yesterday. But in the interest of furthering my channel and answering this question, what I'm going to do is I'm going to melt this bar into shot or into flakes. I'll pour it in water, the molten gold into water, to increase the surface area of the gold. And then I'm going to dissolve it. I'm going to keep track of exactly how much hydrochloric and nitric acid it takes to dissolve the metal. This is metallic gold. And then we're going to get it in solution. I'll precipitate the gold. And then once I get the pure gold powder after that precipitation, we'll do another dissolving of the gold, of the powder, and keep track of exactly how much hydrochloric acid and nitric acid it takes to get this just a touch over 2 troy ounce bar to go into solution. I'm thinking I can dissolve 2 troy ounces in as little as about 250 ml of hydrochloric acid, maybe 300 ml. I don't know. That's what my guess is. 250 to 300 ml of concentrated or 31% hydrochloric acid, and maybe about 20 to 25 ml of hydrochloric acid to get all this gold to go into solution. So let's see what happens. Before we get started, I want to get a weight on the gold bar here. And we're looking at 68.6 grams, 24K gold bar. That's going to be 2.2 troy ounces. I'm going to start out by melting the gold bar and pouring it into some water here to form some granules, increase the surface area, and make it easier to dissolve. Alright, now what we're going to do is pour the water out of the granulated gold. I've got a pan here so I don't pour any of the gold out into the drain accidentally. And then now we're going to add it to a beaker here. Carefully. Glass and metal is not a good combination. Now I got the gold down inside my beaker. I've got my 2.2 troy ounces of gold down here in a 2-liter beaker. I'm going to measure out 250 ml of hydrochloric acid here in a graduated cylinder. Bang, right on the money. 250 ml. Going into the gold. And now what we'll do is cover it up, put it up here on some heat, and we'll start adding small doses of nitric acid to get that gold to go into solution. Every time I dissolve gold, I always add about a half an ml of concentrated sulfuric acid as a preventative measure. Now I'll measure out 25 ml of concentrated nitric acid here. Alright, I've got 250 ml of hydrochloric in there. And now I'm going to put in about 10 ml of the concentrated nitric acid. We'll start dissolving the gold. Now that's about, I got about 13 ml left in there, looks like, so I added what, 12 ml of concentrated nitric acid. Reaction's been going now for about 25 minutes. We'll get a temperature of the liquid in here. And we got 80.2 Celsius, 176 Fahrenheit. Now what I'm going to do is go ahead and add the remainder of the nitric acid, 13 more ml nitric acid. Just going to pour it right in. So that's a total of 25 ml in concentrated nitric in there. The gold has been on dissolving now for an hour. I'm going to add another 110 ml of hydrochloric acid here. Follow that up with 10 ml of concentrated nitric acid. This has been on the heat now for about an hour and a half. I started this at 10:30. It's 12 o'clock noon, straight up right now. Got 360 ml of hydrochloric and 35 ml of concentrated nitric. And so we're just going to let this go until I don't see any more fumes and no more reaction. Let's see where we're at. Get a quick temperature check here of the solution. Looks we got 184 Fahrenheit, 84.4 Celsius. It is 1 p.m., 2.5 hours. And I still got some gold down here to dissolve, so I'm putting in another 10 ml of concentrated nitric acid here. And I just got a little bit of left in the bottom there. This should be dissolved here in just a few minutes, and then we'll proceed to the next step. It's exactly 2:30 right now. Everything has gone into solution. There's no more metal inside there. Took 360 hydrochloric, and was that 45 nitric. Go ahead and turn the heat off now, and we'll let this cool down, filter it out, and do a precipitation. Get the pure gold powder for the next step. Okay, I want to take it off the heat here, and I found a little piece that still hasn't dissolved. So what I'm going to do is put it back on the heat until I get that final little piece in there to go completely into solution. It's now 4 o'clock. And I think I got everything to go into solution now. Let me see what the temperature of this is. I had to crank the heat. Okay, I got the temperature up to, is at 97.4 Celsius, 207 Fahrenheit. And by turning that temperature up, it still took a full hour to get that last little piece of gold to go in solution. The time is now 4 o'clock p.m. But I've got everything in solution now, so we can pull this out off the heat and let that cool off now for the next step in the experiment. I've allowed the solution to cool here for about an hour or so now. It's down to 116 Fahrenheit, 46 degrees Celsius. I'm going to go ahead and add a little bit of ice. I just want to point out I did not add any more acid to the beaker to get the rest of that gold to go in solution. That one little piece that was left down in there. All I did was crank up the heat a little bit, and it went into solution. So right now there's still only 360 hydrochloric, 45 nitric in there so far. The solution's about the temperature of a glass of cold iced tea. We'll go ahead and filter it out now. Put the solution back up here in our beaker and get it ready to precipitate with some sodium metabisulfite. Precipitate gold greater than 2 ounces. I always try to add some ice to keep the solution cool as I add the SMB. So that's what I'm going to do in this case. Now I'll add the sodium metabisulfite, precipitate out pure gold. Been allowed to settle for about half an hour now, 25 minutes. Get a quick stance test, make sure we got everything dropped. And as you can see, status test is absolutely negative, nothing in solution there. Alright, I'm going to pour off the waste solution here into my temporary stock pot. Alright, here's our gold powder. I'm going to give the powder a quick rinse with some hydrochloric acid here to get the chemicals rinsed off the gold. Do another one. More just to make sure we got all that SMB rinsed off of there. Here's our gold powder precipitated and ready to be redissolved for the experiment. Just wanted to point out here I put 250 and 110 ml of hydrochloric acid for a total of 360. I put 12, 13, 10, and 10 for a total of 45 of nitric acid. 360 divided by 45 is precisely 8:1. So I used a ratio of 8 hydrochloric to 1 concentrated nitric to get that metallic gold to go into solution. Now I'm going to measure out, I'm going to try to get 190 ml of hydrochloric acid here in the cylinder. 190, I'm going to try 190 ml of hydrochloric acid for this experiment. There's 190 ml of hydrochloric acid. We'll add that right into the beaker with the gold in it. We'll set it up here on the heat and give it some heat. As before, I'm going to add about a half an ml of sulfuric acid to it, just as a precaution. Concentrated nitric acid, I'm going to measure out 25 ml here. Got a little bit of metal on the edges there around the side of the beaker. I'm just going to go give it a quick rinse here. Okay, I've got 190 ml in here. I'm going to add about 15 ml of the nitric acid now. It's been heating for a while, so it's going to be hot. Should flare up pretty good. I got, looks like about just under 10 ml left in the graduated cylinder there, nitric, so got 15 ml in there. Just going to let the camera run for the whole time it dissolves. This is a 7-minute section of video speeded up 8 times, and right here, watch what's going to happen. See that reaction right there? That's kind of a delayed reaction that happened after I'd added the first bit of nitric. I didn't add anything else in there. That just kind of happened as a delayed reaction. Here I'm going to add the rest of the concentrated nitric acid. So now I got 25 ml of concentrated nitric acid in there with 190 ml of hydrochloric acid and 2.2 troy ounces of pure gold. Alright, to make certain that the reaction didn't stall, I'm adding 25 ml additional hydrochloric acid right here. That's 25 ml of hydrochloric, so I got a total of 215 ml of hydrochloric acid in the beaker now. It's been 10 minutes since I added the acids, or since I added the nitric acid, I should say. And I wanted to get a temperature reading here. We've got it at 81.4 Celsius, 178 degrees Fahrenheit. It's been 10 minutes and just about all of the gold has gone into solution. We'll leave it on there until everything goes into solution. I've got 190 plus 25, that's 215 of hydrochloric and 25 nitric in there so far. That's 2.2 troy ounces of gold. It's been a half an hour since I've added the acids, and I still got a few little bitty grains of gold in there slowly dissolving. So I'm just going to let this go. I got the heat cranked up pretty good. Just let this go until everything goes in solution, and then we'll go from there. Been 45 minutes since we started this. Turning the heat off now. I've got everything in solution in just, what is that, 215 ml of hydrochloric acid and 25 ml of nitric. That's 2.2 troy ounces of pure gold in that much liquid. So I'm going to pull this off and we'll let this cool down now. I've allowed the solution to cool now for about a half an hour. Just to be clear what we got here, I got 215 hydrochloric, 25 nitric, 2.2 troy ounces of gold dissolved in that fluid in this beaker right now. I'm going to get a temperature on it. Looks like we got 136 Fahrenheit, 58 Celsius. So what I'm going to do now is I'm going to go ahead and get some ice here and cool it off so we can do a filtration on it right quick. I've got the solution cooled down now to about the temperature of a glass of iced tea. Got a filter set up. I'm going to go ahead and pour it through the filter again now. Now I'll go ahead and pour it back in the beaker. We'll do the precipitation and then do a melt. And it's kind of freaking me out, man. I hope that's not very much liquid to have that much gold in it. I just hope everything comes back out like I started with. We'll see here in a minute. Pour this right back in the beaker now. Because I've got an excess of 2 troy ounces of gold in the beaker, I'm going to go ahead and add some ice to precipitate. Now I'll add sodium metabisulfite and precipitate the pure gold. Just like to point out a couple of things as I do this. There's losses all along the way here. Every time I transfer the fluid to a different container, when I do a filtering, when I add reagents to the beaker, there's a chance that some of that stuff will splash out of the beaker. So there's going to be some losses here along the way, but I'm not expecting a whole bunch. I should get pretty close back to what we started with, the 2.2 troy ounces. We'll see here in a minute. Gold settled quickly, about 20 minutes, it's completely settled. I'm going to go ahead and pour off the waste solution into my temporary stock pot here. My regular stock pot is full right now, so I'm going to pour this off into this beaker or this flask and hang on to this waste until I empty my stock pot. That refining's coming up, by the way. That stock pot refining is coming. Give it a quick rinse here with some hydrochloric acid. Get all the sodium metabisulfite off of there. A little bit of the gold's going over here into the waste container, but that's okay. This is going in my stock pot. I'll get that back. Do another real quick rinse here with hydrochloric. Settles quickly. I can just pour it right off. Now I'll get the waste container out of the way here. Got a filter set up. We'll go ahead and get the gold into a filter and then do a melt right quick. Transfer the gold into this melt dish. Alright, now we're going to put it over here on the melt table. Melt it up into a bar and see where we're at. Okay, here's our beautiful pure gold bar. Came out real nice. Had a little difficulty melting it there. It was spitting little bits of gold all over the place as I did that. It's a very nice looking bar. Very pure gold. This has been through about 4 refinings now. I'll go ahead and put it up here on the thing, and for the moment of truth, I haven't looked at this. Here we go. It's 67.4. 67.4. That's 2.165 troy ounces, so we lost that much, which was expected. It's pretty close to where we started, but whew, that's a relief. Okay, whew. I'm glad to get that over and get the gold back out. There was a loss of about, what was it, 0.8 grams, and most of that probably got poured into my stock pot. But here's the little bar of gold. Came out pretty good, and a couple things I'd like to say about this. I started this out, I said, well, before I send this gold in to get paid, let's make another video quickly, you know, a few hours and have it done and get it posted. But it ended up taking all day. I started this morning about 10 o'clock, and it is now 8:25 p.m., so it almost took 12 hours, 11 and a half hours or so. But the metal, if you noticed in the video, it took much longer to dissolve the metal. Okay, it took 5.5 hours to dissolve the metal. But then once I got the metal dissolved, precipitated out to powder, it only took about 45 minutes to get all that powder to dissolve. And what did we do? We ended up having this 2.2 troy ounces, well, 2.165 now. Troy ounces of gold dissolved in 215 ml of hydrochloric acid and just 25 ml of nitric acid. I didn't add or take away from anything throughout the entire process. So we now have an accurate number to work with as to how much hydrochloric acid we can expect to use to dissolve some gold. Thanks for watching.